Hello everyone, good morning. I hope you are doing very well, and today we will going to discuss some fixed questions, right, to get 70 out of 70. All right, all right, all right. So is there audio and video is proper? Let me know in the chat box. Then after we will start the session, and you can share your doubts also related to this segment, or if you are preparing and you have any doubt, then you can share with your doubt in chat box, right? Hello, 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 hello. Yes, today we will going to discuss each and every portion, right? So don't worry students, we're going to discuss each and every portion. All right, all right, all right. Don't worry, everyone, don't worry. Okay, fine. Okay, fine. Let's begin. Hi, good morning, Ravi, Girish, Sam. Okay, yes, PDF notes will be available in chat in the description box. You can download from there. Okay, okay. You can get 70 out of 70. You can get 70 out of 70. Basically, I have set up questions, right? Firstly, we will discuss that questions and also mark most sure short questions, fixed questions basically, right? So let's begin the session. Yeah, obviously this session is sufficient. This session is sufficient. Yes. Okay. So let's begin the session. Just put a thumbs up in chat box, then after we will start the session. Just put a thumbs up in chat box, then after we will start the session. Okay. Yeah, I'm sharing this PDF notes. You can download with the link given below in the description box. All right. Okay. Yes. Pakka. Yeah. Okay. Yes. In this session, I have numericals. I have 1 marker question, 2 marker question, 3 marker question, and 5 marker questions. Right. This is a complete package. This is the fixed questions. These are fixed questions. All right. Okay. So just hit the like button. Target 300 likes. And just share the session with your friends. So let's begin. Okay. Let's begin. Last class will, I think PDF available now. Okay. Kindly check PDF notes after the completing of session, right? Okay. Let's begin. Don't waste the time. Let's begin. Firstly, we will discuss 1 marker question. See. How many electrons are present in negative of 1 coulomb charge? This is negative of 1 coulomb charge, right? This is negative of 1 coulomb charge. This is 6.25 into 10 to the power minus plus 18 electrons, just because electrons having 1.6 into 10 to the power minus 19 coulomb. This is negative of 1 coulomb. So that this is the value of E, and Q is basically negative of 1 coulomb. So now you have to find N, right? Q equals to NE. N equals to Q upon E. All right. Now, SI unit of charge is coulomb. Define the electric field at a point. It is the electric force experienced per unit positive charge. That is electric field. SI unit of electric field, that is Newton per coulomb. Right. Okay. It's electric field scalar or vector? Electric field is a vector. Now, electric dipole. What is electric dipole? Electric dipole is just it is set up by 2 equal and opposite polarity of charges by 2L distance. This is basically dipole. Here is Q positive, then this is Q negative, and the distance between these two is 2L. This is dipole. See, define electric dipole moment. Electric dipole moment, that is P equals to 2QL. P equals to 2QL, product of any one charge and the distance between both the charges. Right. State the principle of superposition of electric fields. See, total electric field at a point due to number of charges is equal to the vector sum of electric field at a point C. If E vector you want to calculate, then it is E1 vector plus E2 vector plus E3 vector and so on and so on. Okay, yeah, this is enough. This is enough, just because I'm just providing the PDF notes after completing the session, and I have 30 questions from each chapter, so that no questions out of the session, right? And we also mark the sure short questions. We also mark sure short question, which are fixed question, right? Right. See, draw the pattern of electric field due to isolated positive charge. If you have isolated positive charge, then consider to be electric field lines outward. Electric field lines are outward. This one positive outward. And if you are considering negative, then electric field lines are inwards. That is towards to the charge. Okay. Now, Gauss law. State the Gauss law. Gauss law, what it is? This says phi equals to 1 upon epsilon naught times of total charge present inside the vessel. Right? Okay. State the electric field inside the charge of a spherical cell. This is 0. This is 0. 0. See, what is the target of this session is we have to practice many questions, that is short questions, or you can say in a small time interval we can discuss each and every portion of the chapter. Okay. Okay. So already this session is at 2x mode, right? So don't skip any question, right? So come to the next. State and explain the Coulomb's law. If two charges, this is Q1 and this is Q2, this is Q1 and this is Q2, kept at the effective distance of d, then the force is directly proportional to product of both the charges and inversely proportional to the square of distance between them. Is it? If we remove this proportionality constant, we have a proportionality constant 1 upon 4 pi epsilon naught, also called K, also 9 into 10 raised to the power 9. Okay. Write two differences between polar and non-polar molecules. Polar and non-polar molecules. See, if polar molecules, that center positive charge and negative charge do not coincide. Whereas in non-polar molecules, center positive charge and negative charge coincide. Okay, in polar they possess permanent dipole moment, but in non-polar they don't possess permanent right? They don't possess permanent dipole moment. Okay. Salim, don't worry. Paper will always come easy, right? Ganesh, it's about 90 minutes. We're going to discuss. We're going to close the session within 90 minutes, right? So. Don't deviate. Just focus on the questions. Just because we already at 2x mode, we have a lot of questions to discuss. So I'm just showing the questions, and this is the perfect way to revise your complete syllabus. This is perfect way to revise your complete syllabus, right? See, define linear density of charge and mention its SI unit. See, linear density, amount of charge per unit length. Right? That is Coulomb per meter. Lambda, that is equals to Q upon L. Define the surface charge density, sigma, Q upon per unit surface or per unit area. Right. Define the volume charge density, that is Q upon per unit volume. Right. What is the torque on an electric dipole, first maximum and secondary minimum? See, as you know, torque is what? Tau equals to P sin theta. If the value of sin theta is maximum, then tau is maximum. The value of sin theta is minimum, then the value is minimum. So that tau max when theta equals to 90 degree, See, theta equals to 90 degree, then tau max, just because sine 90 which having value 1, that is tau max, which is equals to exactly P into E. P is the dipole moment, E is the electric field intensity. And torque minimum, torque is 0 when theta equals to 0 or theta equals to 180 degree, right? In both cases, tau max, tau min basically, that is 0. Tau min, that is equals to 0. Okay? Okay. Give the physical significance of electric dipole. What is the actual meaning, physical significance of electric dipole? See, in the study of the effect electric field on an insulator and in the study of radiation of energy from antenna, in both cases, electric dipole used. Yeah, equatorial or axial, that is most important. Don't worry guys, I have lot of questions. I'm just marking the short questions, fixed questions also, right? Scale the electric field lines, two positive charges, two equal and opposite charges, two equal and positive charges. See, if you have positive and positive, then this way, and this is the wrong one. This is also positive. If positive and negative, then electric field lines starting from positive and terminating at negative with open loop. Whereas if you both have positive, then they are repelled each other, right? Now come to the 3-marker question. Mention 3 basic properties of charges. This is too easy. Additive property. Charges are scalar, so that they can add or subtract directly. Conservative property. Charges neither be created nor be destroyed. All right. And quantization property. That is Q equals to plus minus of any. Charges always be quantized. Right. Now, Coulomb's law in vector form. See, Coulomb's law in vector form. For this, okay. Coulomb's law in vector form. Let's see. I'm just writing in simplest way. F vector, that is equals to 1 upon 4 pi epsilon naught Q1 Q2 upon R square into R cap. This is the Coulomb's law in vector form. Okay. Derive the expression for the force on a point charge due to multiple point charge. See, this is a point charge. Here Q1 and Q2. Q1 applied the force and Q2 also applied the force on this. So the net resultant force is this way, right? So F12 vector is K Q1 Q2 upon R12 cap, and F1 basically this is Q1 and this is Q3, right? So F13 is K Q1 Q2 upon K Q1 Q3 upon R square 13 R cap. Just add up vector form. F vector is equals to F12 vector plus F23 vector. Okay. Write the property of electric field lines. They are open loop. See, electric field lines is started from positive and terminated to negative. Electric field leave or enter the charge conductor normally. Electric field lines never intersect each other. Okay. Obtain the expression for electric field due to multiple point charges. That is the same question. That is the same question. But that one for the force, Coulomb's law, basically force, and here it is electric field. So in such questions, you have to sum all the forces, or you can say it is the vector sum, right? That is, if here is a point charge, then the impact due to Q1 charge, impact due to Q2 charge. If you have many other charges, Q3, Q4, Q7, so you can only add E equals to E1 plus E2 plus E3 up to En. Okay. Write the physical significance of electric field. The electric field explains the mechanism by which two charges exert Colombian force on each other. The force acting on the charge in a field can be easily calculated. An electric field is the property of source charge and independent of magnitude of test charge. This is most important question. This is most important question. Just put a mark. This is sure short question. This is fixed question. Right. State and explain the Gauss's law of electrostatics. Gaussian law of electrostatics. You know, as Gauss told, that is total flux emerges out from any closed surface is 1 upon epsilon naught times of total charge enclosed. All right. Okay. Okay. Derive the expression for the torque and also mark this is most important question. This is fixed question. If I am putting this danger sign, that means this is most important question, right? Derive the expression for the torque. See, for deriving this, as you know, this is an electric field and this is a dipole. This is a dipole kept with the angle of theta. Kept with the angle of theta. Then what is the torque? Torque is force into perpendicular distance. Now force is F equals to QE. That is QE. And perpendicular distance is basically this AC. And what this AC? This AC is basically this AB. AB sin theta. And what is the AB? AB is basically 2L. So that AC which is equals to 2L sin theta. AC is basically 2L sin theta or 2A sin theta, which you want. See, so Q into 2A sin theta, and you know 2QA is basically, so tau equals to PE sin, or you can say tau equals to P vector cross E vector. Okay. Yeah, I will upload this PDF. I will upload this PDF, right? After completing the session, I will upload this PDF. Now come to the 5-marker question. If you have any doubt in any derivation, let me know. I will going to derive that derivation. Else we move to another questions. I don't want to expense your much time in this session. I am just putting the questions. I am just showing the questions so that you can imagine that question in your mind, right? If is there any type of doubt, let me know. I will derive that. See, I will give the approach to this question. See, in this question you have to draw this diagram. That is see, you have two charges, that is Q positive and Q negative, that is dipole. In axial condition, here is a point P. Now you have electric field intensity. You have electric field intensity due to this Q negative, EQ negative this way, and EQ positive outward. Now the E is what? EQ negative minus EQ positive. Just put the value of EQ negative and EQ positive and smartly use the distance. From here, this is R. So this distance is basically R minus A. And from here to this is basically R plus A. Just using this and solve it. Now after solving, you have to put 2QA is a P and R is much greater than L, then L square is negligible. The only thing you have to remind, okay, the only thing, right? Okay, I will provide solutions too. Now for non-axial condition, I'm just drawing and just showing. See, this is a dipole, this is Q positive and this is Q negative. Equatorial position, that means the point is at perpendicular bisector. This is a point. Okay, now due to this Q positive, electric field lines are in this way. If this make at angle theta, then there is two components, that is this is EQ positive, so that this is EQ positive sin cos theta. This is horizontal component, EQ positive cos theta, and this is EQ positive sin theta. Now this negative charge will attract this Q naught positive, just because test charge is always Q naught positive. This is the Q naught negative, EQ negative. So to another component, that is EQ negative cos theta and EQ negative sin theta. See, these distances are equal. These distances are equal. If these are equal distances, that means EQ negative, which is equals to EQ positive, so that the perpendicular one cancel out. Only you have to add E net, which is equals to 2E cos theta. 2E cos theta. This E cos theta and E cos theta. That is 2E cos theta. Now putting the value of E and solve it. Putting the value of E and solve it. Okay. You can download the PDF after completing session once, right? Okay. 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 Now, next question. This is most important question. Just put a denser mark. This is most important question. Electric field intensity due to an infinite long wire. You have three surfaces. This is suppose DS1, and electric field lines are in this way. This is basically DS2, and electric field lines are this way. And this is basically DS3. This is basically DS3. And electric field lines also in this way. So as you know, electric field lines, this is E. Phi is what? E ds cos theta. Phi is what? E ds cos theta. And cos 90 is 0. So no flux from here. No flux from here. Only flux from the lateral surface area. So just integrate this ds. This ds is basically 2 pi RL. This ds is basically 2 pi RL, right? Just put it, and you will get this result. This is also important question for infinite sheet. Gaussian for infinite sheet. These two applications are too much important. These are sure short questions. Right? Okay. Now come to the electric potential and capacitance. Then after we'll discuss numericals. Right. So what is capacitor? A device is used to store electric energy called capacitor. What is equipotential surface? Equipotential surface, that means a surface where the value of potential at each point is same, and the work done in equipotential surface will be always 0. 2 mark question. See, what is electrostatic shielding? A method to protect certain region from the effect of electric field is called electrostatic shielding. Right? The method is used to protect sensitive instruments. Right? Electroshielding is that one also. If you are saying like an inverter battery kept on a wooden block or plastic block, just because we want to protect that battery from the earthing, that is also electrostatic shielding. Right? Right? The relation of electric field and potential. Electric field and potential, basically electric field is negative of dV upon dx. That is called potential gradient. This is potential gradient. And what this negative sign shows? This negative sign shows if you are moving away from the charge, then the electric field intensity will decrease. Right? Mention 2 factors of which capacitors of parallel plate capacitor depends. This is also important question. We have 3: area, distance between the plates, and the dielectric constant. All right. T equals to epsilon naught times of A by D. Okay. The parallel plate capacitor with air between the plates has capacitance C. What is the capacitance if distance between the plates is doubled? See, You know C is inversely proportional to distance. If distance double, then the capacitance half. Capacitance, dielectric constants 5 times. You know C is directly proportional to epsilon naught, or dielectric constant basically K. So this is 5 times and this is half. Okay, okay. That is lofi music. That is negative. That is negative of dV upon dl. Okay, sir. So distinguish polar and non-polar molecules. Polar molecules have permanent dipole moment. Non-polar having non-permanent. So come to the 3 marker. Come to the 3 marker questions. You can get 70 out of 70. You can get 70 out of 70, just because we will going to discuss approximately 200 questions, 200 or more than 200 questions, right? And mark the questions which are important, right? Any 3 properties of equipotential surface. First property, never intersect. 2 equipotential surfaces never intersect. Work done in moving up point charge from one place to another is work done is always be 0. Electric field is always normal to the equipotential surface. All right. Yes, you can. Yes, you can. Okay. Okay. Now moving to next. Derive the relation connecting electric field and electric potential. You have to derive EC. V equals to you know KQ upon R square, and E equals to that is I'm sorry KQ upon R, and E equals to that is KQ upon R square. If I am considering this R square is just like R into R, then can you put this KQ as a V? Then E equals to V upon R. E equals to V upon R. Where? If I am putting in differential form, then this is negative dV upon d. Negative dV upon d. Negative sign shows electric field intensity decreasing with the distance. Derive the expression for the potential energy of the system of 2 charges, absence of electric field. See, you are taking, see, this is a charge Q, right, at infinity, putting at point P. There is no electric field. That means work done in bringing this charge is 0. Work done in bringing first charge will be 0. But you are moving another charge. You are moving another charge, that is Q2. Then this Q1 charge repels this Q2. I think so. This is 1 upon 4 pi epsilon Q1 upon 4. Q1 upon R. Q1 upon R, right? So W2 is basically V into Q2, yani 1 upon 4 pi epsilon naught Q1 Q2 upon R. Now total work done is W1 plus W2. W1 is 0. W2 is 1 upon 4 pi epsilon Q1 Q2 upon R. So U equals to 1 upon 4 pi epsilon naught Q1 Q2 upon R. All right. If any doubt in any questions, just let me know. Okay, see, derive the expression for capacitance, parallel plate capacitance. As we know, we have 2 parallel plates, that is M and N. If I'm putting positive charge over this parallel M plate, then it will spread on the surface of M, and due to which an induced charge, negative charge inside the plate N. In this situation, we want to calculate capacitance. So see, in capacitance you have to solve what it. See, you know C equals to Q upon V. So just calculate the value of this V and put it, right? So V equals to E into D. V is basically E equals to V upon D. So that V equals to E into D. That is electric field intensity into D. Now, what is electric field intensity due to this charge? As we know, between these, see, if this positive charge outward, this one also outward, the only field, this positive charge inside and this negative charge is also inside. So we add up. So parallel plate, in parallel plate, equals to 1 upon 2 sigma, right? But you have two plates, so 1 upon 2 sigma plus 1 upon 2 sigma, that is equals to 1 upon sigma, right? 1 upon sigma. So equals to sigma upon epsilon naught. Sorry, I'm sorry. Equals to sigma upon sigma upon 2 epsilon plus sigma upon 2 epsilon. Just add up this, equals to sigma upon epsilon, right? Sigma upon epsilon naught times of d. Just put it. V equals to E into 2 q upon a epsilon naught times of d. Just putting this, q to q cancel, that is a times of epsilon naught by d. C equals to epsilon naught times of a by d. Okay. Now derive the expression for the energy stored in charged capacitor. Energy stored in charged capacitor. That is half CV square. Or W equals to Q square upon 2C. Obtain the expression for effective capacitance of two capacitors connected in series. Effective capacitance, two connected in series, right? In series combination, V equals to V1 plus V2. Right? Just put V equals to Q upon C1, V2 equals to Q upon C2. Putting these two, V equals to Q upon C1 plus Q upon C2. That is Q 1 upon C1 plus 1 upon C2. Okay. In similar way, we have to derive U, potential energy, U equals to minus P cos theta. Right. I think right. See, you can download PDF from here. I think you can join Telegram channel also. From there you can download the PDF notes and right. See, you can download there will PDF direct link also. After completing this session, I will share. After completing this session, I will share channel also. Okay. From there you can download the PDF notes and and right. See, you can download there will PDF direct link. Come to the current electricity. After completing this session, I will share. Once the session completed, after completing the session, I will share channel also. You can PDF notes. You can download the PDF notes. And and right. Now come to the current electricity. Define current density. Come to the current electricity. Current density, as you know, J equals to I upon A. I is the current and A is the area of cross section. Once the section completed, what is difference of section? This is the average velocity of a free electron. You can download the. This is the average velocity with the free electrons are drifted in a conductor under the influence of electric field. Come to the current electricity. Define current density. Come to the current electricity. Current density, as you know, J equals to I upon A. I with the current and A is the area of cross section. What is this is the average velocity of mobility. Magnitude of the average velocity with the per ions are drifted in a conductor under the influence of electric field. Come to the current electricity. Define current density. Come to the average current density. J equals to I upon A. I with the current and A is the area of cross section. What is this is the average velocity of mobility. Magnitude of the average velocity with the per seconds are drifted in a conductor under the influence of resistive electricity. Define current density. Rho equals to the average current density. J I upon A between per square meter. Average velocity of mobility. Magnitude of the average velocity with the per seconds are drifted in a conductor under the influence of resistive electricity. Define current density. Rho equals to the average current density. right? The size of resistance offered by the EMF of the magnitude of the when it is open circuit Okay. Now it's clear. Now it's clear. Okay. Now it's clear, I think. Now it's clear. No echo, I think it's clear. Okay, guys. Now, moving to question number 11. This is 1 marker question. Right. What is the significance of Kirchhoff's second law? This is conservation of energy. Just because it depends on voltage. This is voltage law. This is KVL basically. KVL is conservation of energy. And what is KCL? KCL, that means this is conservation of charge. This is based on current, that is Q upon T. And V basically this is work done upon charge. Is it? Okay. Now, write the balancing condition of Wheatstone bridge. Wheatstone bridge, that means the current from galvanometer is 0. That means the branch of galvanometer was open. Right. Principle of meter bridge. This is based on the Wheatstone bridge. Balanced Wheatstone bridge. This is based on the balanced Wheatstone bridge. Is it? Okay. Now moving to 2 marker question. See, write the expression of drift velocity in terms of current and explain the terms used. So as we know, I equals to V na. It's VD VD, that is drift velocity. This is drift velocity. Right. E is basically one electronic charge, or this is electronic charge 1.6 into 10 to the power minus 19. N is number of charge. This is number of charge. And what about A? This is area of cross section of conductor. This is area of cross section of conductor. Okay. Aditya, is there any problem? Fine. Now, state and explain the Ohm's law. This is too much easy question. See, if you have a closed circuit, just like this, then just applied voltmeter parallel with the resistance. This is potential difference. This is ammeter. If I am closing this key, I ampere current passing through this resistance, then V is directly proportional to I. If all the physical conditions are remains constants, then the current moving in this closed circuit is directly proportional to the electric potential applied across the resistance. That is V equals to IR. V is basically potential difference, I is the current and R is the resistance. And also draw a VI characteristics. See, also draw a VI characteristics. That is R. This constant, R is constant for the conductor. Right. Now, mention the limitations of Ohm's law. What are the limitations of Ohm's law? See, Ohm's law only valid for the conductors. It is not valid for semiconductors, that is diodes, transistors, just because they don't have this static resistance. With the rise of temperature, resistance of the conductor, resistance of semiconductor will decreases. So that it is not applicable for semiconductor. It is not applicable for superconductor. It is not applicable for vacuum tubes. Alright. What is the ohmic device? The device which follow the Ohm's law, that is the ohmic device. Right. the device obeys the Ohm's law, it's called ohmic device. Right? Metallic conductors are normal temperature, voltmeter, ammeter, these are the ohmic device. Right? Okay, what a non-ohmic device? The device which do not obey Ohm's law, that is called non-ohmic device. That is semiconductor device, that is transistor, diode, vacuum tubes, right? They are non-ohmic device. Now come to the state and explain Chop's junction rule, current rule. This is most important. Just put the mark, right? What it is? This means there will be no current drop at any junction. That means incoming current is equal to outgoing current. In an electric network, the algebraic sum of current at node is always B0. I1 coming towards to the P, I2 coming towards to the P, and I4 coming towards to the P. So that I1, I2 and I4 considered as positive, then I3 and I5 considered to be negative. But this is not fixed. If you are considering the leaving current is positive, then incoming current will be negative. Okay? Okay. Fine. So I1 plus I2 and I4 taken as positive, and I3 and I5 is taken as negative, so that this negative moves this side. So I1, I2 plus I4, which is equals to I3 plus I5, or you can say summation of I is equals to 0. This is basically current rule. And what is voltage rule? The potential drop and the total potential applied in the circuit which having the algebraic sum is 0. See, in an electric loop, the algebraic sum of IR, that is current into resistance, which is called V, potential drop, product is equal to the algebraic sum of the EMFs. That is, see, for this you have to use a loop rule, right? Just draw a loop and write the conventional current. If conventional current into the direction, then taken as negative. See, if we are two rules, if you are moving in cell negative to positive, then this EMF taken as positive. If you are moving positive to negative, then taken as EMF as a negative, right? If the direction of current in this way and you are also moving in this way, right, then this will IR. And if you are moving, if the current direction of current in this way and you are moving in the loop in opposite direction, then this is as negative of I. Okay? So Janya, is if any problem like this, then I will update with the team, and surely you will get PDF notes. Surely you will get PDF notes. Don't worry, guys. Okay. What are uses of potentiometer? Potentiometer, see, this is used to find internal resistance of the cell and used to compare EMF of two cells, right? Okay. Now come to the 3-marker question. Mention the factors where the resistance of the conductor depends. Resistance of the conductor depends only on 4 factors. That is, resistance is directly proportional to length, resistance is directly proportional to 1 upon A. That means inversely proportional to area. That is, resistance is L upon A. If I am removing this proportionality constant, I have a constant that is called resistivity. This is called resistivity. Okay, resistance of temperature is also directly proportional to temperature. If you rise the temperature of the conductor, then resistance will also get increased, right? But in semiconductors, it's opposite, right? Okay, and material of the conductor. That is, material will be copper, aluminium, right? Iron. Now, derive the expression. This is most important question. This is most important question. This will come to your examination paper. All right, this is too much important question. Yeah, I have numericals also. Don't worry, students. I have numericals also. Don't worry. Keep patience. I'm planning the entire session in such a way so that you can revise your each and every topic, each and every question. Also mark the most important questions, short question, fixed questions, all right, along with numericals, 1 marker, 2 marker, 3 marker and 5 marker questions. So my suggestion is you have to learn this derivation. You have to learn this derivation anyhow. This will come in your examination, right? Anyone having any doubt, then let me know. I will derive, right? Yeah, you can, Varun, you can, Varun, you can. Right. So Vd equals to E tau upon m. This is too easy. The acceleration of free electron due to E is C. A equals to F upon m. Comes from F equals to Ma. Right? So F equals to E into E. This comes from F equals to QE. Q is basically negative of E. Now comparing these two, you can get A equals to E upon M. Now you know that V equals to U plus AT. First equation. Now just put V is Vd and T is tau. Right? So Vd is equals to A tau. U is 0. Initial velocity U is 0. Then Vd equals to A tau. Just skip A. E upon M. E upon M tau. This is very important. Right? This is very much important. Okay, sir. Obtain the expression for current in terms of the drift velocity. See. Already told. This is important. We learned I equals to VDENA, just Vina. To make a jingle, I am just shuffling these terms. I equals to VDNA. Okay, and see, these are too much important. So I'm just putting this danger sign here also. I'm just putting the danger sign here also. This is the vector form of Ohm's law. See, this is a current carrying conductor. If I am applying potential difference across this conductor, an electric field set up here, positive, here negative, then electric field set up. This electron having influenced velocity, that is called drift velocity, towards to Vd. Now I equals to V upon R and R equals to rho L upon A. So what I is, I equals to V upon rho L upon A, that is Va upon rho L. Okay, and as you know, current density, that is equals to I upon A. Just see, I upon A, which is equals to Va upon rho L into A cancel out. I upon A is J, that is V upon rho L. Okay, now V upon L is what? This is potential gradient, that is called electric field intensity. So J equals to electric field intensity upon L, right? J equals to electric field intensity upon L. Okay, I'm sorry, V upon L is basically E upon rho, and 1 upon rho is called sigma. 1 upon resistivity, reciprocal of resistivity is conductivity. So J equals to sigma E. These are short questions. And very easy. All right. Now come to the 5 marker question. This is derive the expression for equivalent EMF and equivalent internal resistance of two cells connected in series. If you connected two cells in series, then potentials are also add up, right? Potentials are also add up. See, E1 plus E2 minus IR1 plus R2, right? V equals to E minus IR, just keep it, R equals to R1 plus R2. Now, in same way, if you are going to in parallel combination, that means in parallel combination, potential will be same. Potential will be E only, right? E only. E, that means V plus IR, right? But what is the internal resistance of these cells? Internal resistance basically, see, 1 upon R equivalent for the internal resistance, 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on. That means R equivalent equals to R upon N. R upon N. And external resistance, R external is basically R. So, R equivalent total resistance R upon N plus R. So, if we are considering current that means E upon R upon N plus R. This is for parallel combination. This is for parallel combination. Yeah, I am promising to provide the PDF notes. Yeah, obviously. And as Janya told that previous one also not provided. So don't worry guys. I will provide that one also. Right? It will take 1 more hour. It will take 1 more hour. So now obtain the explain combination Wheatstone bridge. This is also most important question. This is also most important question. Most important question. Right? Anyone having any doubt in Wheatstone bridge, then let me know. See, Wheatstone bridge is basically 4 resistors connected at the sides of any rhombus. One diagonal connected with the galvanometer and another diagonal connected with the external potential difference, right? V. If P upon Q is equals to R upon S, which are balanced condition, then the current IZ will be 0. That is open circuited. This is the balance condition of Wheatstone bridge. And why it is used? It is used to find any unknown resistance. If S is an unknown resistance, then S equals to RQ upon P. Okay. Now you guys told me that sir numerical. This is numerical. See, this is numerical. A battery of external resistance 3 ohm and connected to a 20 ohm resistor and potential difference across the resistance is 10 volt. Another resistor is 30 ohm is connected in series with the first resistor and battery again connected to the combination. Calculate the EMF and terminal potential. See, R equals to 3 ohm, R equals to 20. This is internal, this is external, V equals to 10 volt. Then just calculate EMF. E upon R plus R. E upon R plus R. Okay. V R plus R upon R, that is 11.5 volt. In the same way, RS is 20 plus 30, that is 50. Internal resistance will be same, that is 3 only. V equals to V upon RS, that is RS जो external resistance. E upon R plus R. E RS upon R. E is 11.5. RS 50. 50 plus 3, that is 10.84. Okay. Similarly, this question just apply current rule. This is current rule. This is loop rule. Just apply, and you will get 2 equations. Apply KVL in this question. You can get answer, right? This is questions from the internal resistance. So I'm just moving ahead on the chapter moving charges and magnetism. I'm moving ahead to moving charges and magnetism. Okay. But promise me, you have to solve these questions after completing the session. Right. Before going to your examination hall, please try to read all these questions. And don't escape the short question. Marked with danger sign. Okay. Does a neutron experience force? No. Since charge on neutron is 0, then no force experience. Okay. Rest charge can experience magnetic force. What do you guys say? Rest charge can experience the magnetic force? Anyone? Let me know in the answer in the chat box. Rest charge can experience? No. Rest charge can never be experienced magnetic field. See. Rest charge can experience only electrostatic fields, but moving charge can experience electrostatic fields as well as magnetic field. Moving charge having electric field as well as magnetic field, so can be affected from electrostatic field and magnetic field both, but rest charge only affected by electrostatic field. Just remember, right? Now Write the expression for the force experienced by a straight current carrying conductor, that is F equals to BIL sin theta, F equals to BIL sin theta or L cross B, right? If a current carrying conductor putting in a uniform magnetic field, then the force experienced by that conductor. What is this case? This is a uniform magnetic field, and if I am putting a wire of length L, I current carrying from this conductor, then what is the force experienced by this wire? Just because this wire having a current, that means this wire also behaves like a bar magnet, or you can say this wire, sorry, bar magnet, this wire also behaves like a magnet, so that I have two magnetic fields. One of them is due to current carrying conductor and another one already exists in the form of uniform magnetic field. So that F equals to I, as you know, current is a scalar quantity, so that I L vector cross B vector. If you are removing this cross product, you will get sin theta. Okay. State and explain ampere circle law. This is too much important question. This is short question. This is fixed question. B dot dl equals to mu naught times of I. B dot dl is equals to mu naught times of I. This is same like Gauss theorem. You know, Gauss theorem is used to find electric field intensity at any point. And the simplest part is that just put that charge enclosed by a symmetrical surface. In the same way, you have a current carrying conductor, then you want to find magnetic field at any point, then just point a symmetrical circular plot or symmetrical draw and the point on that surface. At that time, the closed integration of B dot dl equals to mu naught times of I. Okay. Yeah, obviously you can get, but if you are solving only 3 model papers, then I think it was too risky, right? Okay, right. Define ampere SI on it. Current, writing expression for the force between the parallel conductors. See, F upon L, that is equals to mu naught I1 I2 upon 2 pi d. This is the force of two parallel current carrying conductors. The 1 ampere is defined as the current which, when flowing in each of two infinitely long straight conductors separated by the distance of 1 meter, then free space experience a force of 2 into 10 to the power minus 7 Newton per meter between them. Now, you can skip this question. Alright, the nature of force between two parallel conductors carrying current in same direction, in opposite direction. As you know, in same direction attraction, in opposite direction repulsion. In same direction attraction, in opposite direction repulsion. See, in same direction attraction, in opposite direction repulsion. There is repulsion, there is attraction. See, as you know, if I am applying on first wire, here is cross, and due to this second wire, just put curl rule. Outward, inward, outward, that means attraction. See, for this wire, this is cross, and for second wire also, this is cross. Two field lines in same direction, that means it's repulsion. This is too simple, too easy. Now, 2 marker question. Write the expression for magnetic field acting on a charged particle moving in uniform magnetic field. Explain the terms. See, F equals to QVB sin theta. This is QVB sin theta. F equals to, this is QV cross B, right? This is the moving charge in uniform magnetic field. This is the moving charge in uniform magnetic field. When the force on a charge moving on magnetic field is maximum or maximum, obviously F equals to QVB sin theta. When sin theta is maximum, at 90 degree F maximum, at 0 degrees F minimum. F is 0 basically, and in this case F is QVB. What is Lorentz force? See, force experienced by a moving charge particle in region of containing both electric and magnetic field, then it is called Lorentz force. That is, for Lorentz force is basically experienced electric force and magnetic force. This is a uniform magnetic field, and you have a charge, this is a charge Q, moving in uniform magnetic field. Then this charge having also current, that means it behaves like a magnet, and this charge experience electric field and magnetic field both. So that electric field is QE, magnetic field is QVB sin theta. So Q common, that means E vector plus V cross B vector. Now this is also most important question, one of the most important question. Biot-Savart law. For Biot-Savart law, you have a current carrying conductor. If I ampere current passing through it, L is the length of the conductor, then just consider magnetic field at point P. So put an integral element dl, and this is the direction of dl vector. If the distance between them is r, then dB is directly proportional to I dl sin theta upon r square. And what is theta is? Theta is the angle, right? Okay. Define Bohr's magnetron and mention its value. You can skip this question. You can skip this question. Generally, I already take that session, that is individual sessions for 1 marker question, 2 marker question, 3 marker question and 5 marker questions. All right. Now 3 marker questions. On what factors force experienced by the charged particle moving? See, this is all C, F equals to QVB sin theta. Now you can explain QVB and sin theta only, right? This is F equals to BIL sin theta. You have to explain individually. Now come to the state Biot-Savart law. Directly proportional to length dl, and this one ideal sin theta, as we all earlier discussing. See, how convert galvanometer into ammeter? Galvanometer converts into ammeter, then use a resistance, shunt resistance, R shunt with minimum value, in parallel combination, and if you are using this resistance, shunt resistance with maximum value in series combination, then it behaves like a voltmeter, okay. So moving to next, derive an expression for magnetic field at a point inside a long current carrying solenoid using Ampere-Circuit law. See, if my point is here, then I just draw a uniform rectangular surface, and now calculating magnetic field intensity at this point. See, P to Q inside, Q to P perpendicular, R to S. See, R to S there is no magnetic field, so 0. Here theta equals to 90 degree, that means 0. Here theta equals to 90 degree, that means 0. Only the magnetic fields due to PQ. And the length of this is L, so that it is BL. So B dot dl equals to BL. Applying Ampere-Circuit law, that is mu naught times of I, mu naught times of Li, that is mu naught times of Ni. Okay. Now derive the expression for magnitude of magnetic field at any point on the axis of circular current carrying coil. Anyone having any doubt related to this question? This is also very simple question. See, I'm just drawing in what another diagram. See, this is a current carrying conductor. Now plot the axis and point P. If I'm considering this is the DL, then this is perpendicularly acting on this, right? That means if I'm considering at DL wire, just applying curl rule, then where DB is in this way. All right. So I have two dB, one dB sin theta, and this is dB cos theta. In the same way, this DL exactly opposite. If you are here, then the direction of DL is in this way. And see, This is dB also, then this is dB sine theta, and this is dB cos theta. Now, dB cos theta for each component of dl will cancel out, only the add-on of dB sine theta. So, if you want to B, then summation of dB sine theta, or you can say B, you can integrate dB sine theta. You can integrate dB sine theta. Okay, summation of dl, you can 2 pi r, or integration. This is also important question. Okay, okay. Now, this is also important question. Force between two parallel current carrying conductors. Yesterday we were derived this. And in this part, define 1 ampere is 1 ampere is, define 1 ampere. This is too important. This is too important. Okay. 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 Just give me a minute. Just give me a minute. Then after, just give me a minute. Then after, we move to another question. Moving to another question. Moving to another question. Just give me a minute. Just give me a minute. Just, yes, yes. Okay. 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 See, obtain the expression for the torque. Obtain the expression for torque. Obtain the expression for the torque, right? Acting on the rectangular loop placed in an uniform magnetic field. Placed in uniform magnetic field, right? Placed in uniform magnetic field. This is a loop. PQRS is the loop and B is the uniform magnetic field. Then the torque acting on any one branch, just taking, see, in this branch, torque acting opposite, so cancel out, only the torque applying on these two. So the thing is force into perpendicular distance. Force into perpendicular distance. Force is BIL and perpendicular distance is b sin theta, that is BIA sin theta. L into B is area and M equals to LA, that means MB sin theta, or you can say BIA sin theta. NBIA sin theta, N is the number of turns. N is the number of turns. Right. Now see, numerical problems. A stray of length pi by 2 meter is bent into a circular shape O. The center of the circle, right, and P is the point on its axis. P is the point on axis which is at the distance of 3 times at the radius O. Current of 1 ampere is passed through it. Then calculate the magnitude of magnetic field at the point O and P. See, you have to find magnetic field at O and P both. Right? Right? So, at the center B equals to mu naught times of 4 pi 2 pi Ni by R, or you can learn B naught is equals to basically 2 pi, this is 2. That is mu naught upon 2 Ni upon R. Ni upon R. Just putting the value and you can solve. Right. Outside the point, already derived mu naught upon 4 pi 2 pi and I R square upon R square plus X square, just putting and you can get your answer. Okay. Okay. Now coming to the magnetism and matter. Coming to magnetism and matter. Magnetism and matter. Right. See, can two magnetic field lines intersect? No, never. Two magnetic field lines are never intersecting each other, just because at any point in magnetic field, the tangent over the magnetic curve showing the direction of magnetic field, and at the common point, direction of two magnetic fields never possible. Right. What is magnetic dip? Dip at a place is defined as the angle made by the direction of Earth's total magnetic field with horizontal drawn in the magnetic meridian. Similarly, magnetic declination, the angle between the magnetic meridian and geographic meridian is called declination. Right? Is called declination. Yeah. Chaman Sharif. Yeah, sure. Okay. How does the value of BH varies from equators or pole? As you know, BH horizontal component is maximum at equator and 0 at poles, just because it's a horizontal component. Define magnetization of magnetic material. It is defined as the ratio of net magnetic moment developed per unit volume. Net magnetic moment developed per unit volume. And what is magnetic susceptibility? The ratio of magnetization developed in the material to applied magnetic intensity. To applied magnetic density. Alright? Okay. See, a question. Susceptibility of ferromagnetic substance is 3000. What is its relative permeability? That is mu r equals to 1 plus x plus 1 plus 3000, that is equals to 3001. Okay. For material susceptibility low and negative diamagnetic material, this is also important. See, state Gauss law of magnetization, that is B dot ds will be 0, just because see, if you are considering a closed vessel, this is a closed vessel, so we are just considering some electric field lines inserting at this end, just using different at this end. As much magnetic flux entered this phase as same like moving outward from this phase, so that summation of B dot ds any closed surface will be always 0. Right. Write the formula for time period of oscillation for small magnetic needle in uniform magnetic field, that is T equals to 2 pi under root of I upon MB. Right? Right. Okay then. Moving to next. 2 marker. 2 marker. Mention the properties of magnetic field lines. See, magnetic field lines, closed loop, closed loop. As you know, outward from north to south and inward south to north. Magnetic field lines do not intersect each other. The tangent drawn on the magnetic field is always showing the direction of magnetic field. Alright. State the explain Gaussian magnetism. The net magnetic flux through any closed surface always be 0. Right. Just because we are considering total incoming magnetic flux is equals to total outgoing magnetic. Okay. Magnetic dipole moment, it is same as electric dipole moment, that is equals to P equals to 2QL. In the same way, M equals to Q into 2L. Any pole strength and the distance between both the poles. Now coming to electromagnetic induction. Coming to electromagnetic induction. Magnetic flux, Weber or Tesla? Unit of magnetic flux, Weber or Tesla? Right? Minus d phi upon dt. Right? That is from EMF, and phi equals to BDS cos theta. BDS cos theta. Here, BDS cos theta. Mention the significance of Lenz's law. Significance of Lenz's law. See, conservation of energy, or it gives the polarity of induced EMF. Conservation of energy, or it gets polarity of induced EMF. Right? This negative sign basically comes from the Lenz's law, and Faraday's told that is the rate of change of flux is directly proportional to EMF induced at the coil. So, name the law which give the polarity of induced EMF. Lenz's law. This negative sign due to Lenz's law. What is motional EMF? Induced EMF in a rod moving in a plane perpendicular to magnetic field is called motional EMF. It's called motional EMF. Okay. 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 Mention the expression. Mention the expression for motional EMF, that is E equals to BLV. Equals to BLV. B is the strength of magnetic field, L is the length of the conductor, and V is the velocity of the conductor. Right? On what principle AC generator works? Electromagnetic induction. Electromagnetic induction. Get the expression for the energy stored, that is U equals to half Li square. See, energy stored, as you know, see, U equals to half Li square. Right? In capacitor, energy stored, energy stored is basically half CV square. Right? This is same like Ke equals to half mv square. Now come to 2 marker. State and explain Faraday's law. Faraday's law. As Faraday's told, if you have a magnet and a coil, then if a relative motion occurred between the coil and this magnet, then due to change in magnetic flux linked into the coil, EMF generated across this coil, and that is EMF is directly proportional to the rate of change of flux, d phi upon dt. Mention the application of eddy current. Eddy current used in speedometer, induction furnace, magnetic brakes in trains. All right. Now moving to next. Now moving to next. Give the expression for self-inductance. Self-inductance L equals to mu naught mu r pi n square r square L. L is the length of the solenoid, n is the number of turns per unit length, r is the radius of solenoid, and mu r is the relative permeability of medium inside the coil. Alright, you can remove this one also. You can write only L equals to mu naught pi n square r square L. Okay. Mention the factors on which self-inductance coil depends. Length of the conductor, see, length of the conductor, radius of the conductor, number of turns, length, radius and number of turns, length, radius and number of turns. Alright. Also it depends medium inside the coil. Also it depends medium inside the coil. 3-marker question. Come to the 3-marker question. Okay. Describe the coil magnet experiment Faraday's and Henry to demonstrate electromagnetic induction. In this, they use a coil and magnet. When this magnet coming towards to this coil, then a rise of magnetic flux inside the coil, which leads to generate EMF across this coil. And when this magnet moving outward from the coil, then there is again number of magnetic flux decreases. That means change in magnetic flux. Firstly increases, then decreases, increases and decreases, due to which an EMF induced across this coil, and that is E is directly proportional to d phi upon dt, rate of change of flux. Okay, students, okay. State and explain Lenz's law, E equals to minus d phi upon dt. Now coming to this one is important. This one is too much important. Just put danger sign over here. Derive the expression for electromotive force induced in a rod moving perpendicular to uniform magnetic field. See, x is basically uniform magnetic field inside the paper, and this is P S R Q. This is a conductor, and the arm PQ is movable with the velocity v. Just like this. This arm is movable. This arm is movable. Now, if this arm coming towards SR, then the loop will going to be smaller. See, if this PQ is here, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 field lines inside. If this moving outward, that means these magnetic field lines increases. That means if I change the position of the arm, arm PQ, then it will changes magnetic field inside the coil. That means see, d phi equals to BA cos theta, that means BLX cos theta, that means BLX, right? E equals to minus d phi upon dt. And what is phi? BLX. A is basically area is basically length into width. Area is basically length into width. L into X. L is a length and X is a width. So this is L into X. And cos theta is 0. Right. Cos 0 is 1. So minus d phi upon BL Vx. BL is constant, dx upon dt. This is V. This is V. Right. So V is negative of dx upon dt, that is E equals to BL. Obtain the expression for the magnetic potential energy stored, right? See, this is W equals to integration of dW, and you know power. What is power? Power equals to rate of doing what? dW upon dt, right? That is equals to E into I. E into I basically comes from, this is EMF V and this is current. P equals to IV in electricity, but E equals to LdI upon dt. From self-inductance, as you know, EMF equals to LdI upon dt, so that dW upon dt, which is equals to EI, that is LdI upon dt. Now dW is what? dW is what? L I di. One I also. So Li di, integration of Li di. L is a constant, integration of I is I square upon 2, half Li square. I square upon 2, just half Li square. Okay. Now see, level diagram of AC generator. This is it's a very simple question, so don't need to discuss. So explain the instantaneous induced AC current. See, phi equals to NBA cos theta. Now theta is just omega t. Theta is just omega t. Just because omega is the angular velocity, angular displacement upon time, that is theta equals to omega t. So that sine theta is now considered as sine omega t, right? So E equals to minus d phi upon dt and phi equals to NBA cos omega t. NBA common, differentiation of cos omega t. Differentiation of cos omega t. Differentiation of cos omega t is basically negative of sine omega t, and differentiation of omega t is multiplied with this. So negative of this into omega. So NBA omega sine omega t. These term, these NBA into omega considered as E naught. So E equals to E naught sine omega t. That is called peak EMF. That is called peak EMF. Now coming to alternating current, and that's how completing our first book, our first portion, first book. Okay, write the expression for mean value of alternating current. Mean value of alternating current, Vm equals to 2 upon pi V naught, right? Mean value, right? Expression for RMS, RMS is 1 upon root 2 V naught, and mean current 2 upon pi I naught, IRMS, that is 1 upon root 2 times of I naught, right? Resonance in LCR circuit, it is condition of maximum current in LCR circuit. That means in resonance condition R equals to 0 or Z equals to 0, right? Write the expression for resonant frequency, F equals to 1 upon 2 pi under root of 1 upon LC. And what is the resonance condition? Then XL equals to XC and XR is equals to 0, Z equals to 0. In such case, L omega equals to 1 upon C omega. Okay. What is the quality factor? Quality factor is just output frequency upon F2 minus F1. See, quality factor of LCR circuit is defined as the ratio of resonant frequency to the bandwidth. Resonant frequency to the bandwidth. Resonant frequency to the bandwidth. Resonant frequency matlab F naught upon bandwidth, that means F2 minus F1. F2 minus F1 is bandwidth. Okay, moving to next question. Coming to next question. See, what does resonant? See, electrical resonance in LCR circuit is the condition for the maximum current through it. In this condition, as you know, Z equals to 0 and R equals to 0. In such case, as you know that Z equals to under root of, in LCR circuit, Z equals to under root of XR square plus XL minus XC square. Is it? Now this term is 0. This term will be 0. XL minus XC. XL minus XC. XL, that means omega naught L minus XC 1 upon omega naught C whole square. This 0 square and root cancel out, that means omega naught L, which is equals to 1 upon omega naught C. After this omega one sided, that is omega naught square, and L comes here 1 upon LC. Omega is under root of 1 upon LC. Omega is a 2 pi F naught, right? So F naught equals to 1 upon 2 pi N, the root of LC. Mention 3 sources of energy losses in transformer. See, magnetic flux link, flux leakage की वजह से, flux leakage, magnetic flux leakage, second, Ohmic losses, that is resistance of the conductor, that is copper loss. AD current loss, hysteresis loss, that means magnetization and demagnetization. In the process of magnetization and demagnetization also losses available. Eddy current loss, as you know. Okay, now come to the 5-marker question. These are very easy question. Obtain the expression for the impedance current in the LCR circuit. See, in LCR circuit, if you want to calculate impedance, just draw a phasor diagram. See, in this way you know VR, in this way you know VL, and this way in this way VC, this way VL. Now just solve VL and VC. If you are solving VL and VC, you will get VL minus VC, and this is VR. So the net is V. How to calculate this? To calculate V, you have to calculate these, that is under root of VR square plus VL minus VC square. Just put VR as a IXR square plus IXL minus IXC whole square. Now I square common, I square common, that means I common. So x square plus XL minus XC square. So just putting V upon I here, which is also called Z, that is impedance, under root of XR square plus XL minus XC square. Or you can say Z equals to under root of what it is, R square plus XL, that is omega L, minus 1 upon omega C square. This is the impedance of LCR circuit. This is the impedance of LCR circuit. Okay. And if we are considering what is the phasor, that is this phi. What is this phi? Phi is basically, I am just solving here. Phi is basically tan inverse of this perpendicular, that is VL minus VC. VL minus VC upon VR, which is phi is equals to tan inverse of VL minus VC, that is IXL minus IXC upon IXR. I cancel out, that means phi equals to tan inverse of XL minus XC upon R. XL minus XC upon R. Okay, or you can say phi equals to tan inverse of XL, that means omega L minus 1 upon omega C upon R. Okay. Now some numerical problems also given. So you have to solve these. See, this is the question from LCR circuit. This is the question from LCR circuit. This is LCR, and the value given, R equals to 50, L equals to 0.5 hertz, and C equals to 200 microfarad. Microfarad is basically 200 into 10 to the power minus 6 farad. Now you have C, V, F frequency given. So that omega equals to 2 pi F. So 3.14 into F equals to 50. This is basically 100 into 3.14, which means this is 31.4. This is the value of omega. Just put it, R square L omega minus 1 upon C omega whole square. Okay. Similarly, obtain the resonant frequency, L given, C given, R given. R is basically 0. In resonant frequency, R is 0. That means F naught, which is equals to 1 upon 2 pi 1 upon under root of LC. Just put the value of L and C here. Okay. There are some more problems. You have to solve these 4th, 5th and 6th. That's how we completed the first portion of your book NCERT. Alright? Alright. Now moving to second part, basically from electromagnetic waves. From electromagnetic waves. See, what are electromagnetic waves? The electromagnetic waves are those waves in which these are sinusoidal variants of electric and magnetic field vectors at right angles to each other, right? Electric field and magnetic field both are perpendicular to it, right? That is electromagnetic waves. And what is electromagnetic spectrum? The orderly distribution of electromagnetic radiation arranged according to their wavelengths or frequency is called electromagnetic spectrum. And what is the source of electromagnetic wave? Accelerated charged particles are the source. Electromagnet who experimentally demonstrate? Hendrik Hertz. Arrange IR rays. This is important. This is important. I think this was coming into 22 or 23, right? Gamma rays, visible rays, X-rays, gamma rays, X-rays, then visible rays, then IR rays. Arrange microwaves, gamma rays increasing in increasing order, microwaves, then visible, then X-rays, then gamma rays. Write the wavelengths of the range, that is 0.1 angstrom to 100 angstrom. Right? Right? Okay. And angstrom is basically 10 to the power minus 10. 2 marker. Right? 2 uses of gamma rays. They are used in treatment of cancer, produced in nuclear reactors. Right? Write any 2 uses of X-rays: bone fractures, cure skin disease. This is very easy chapter, and it's from this chapter you have to learn range of all the waves and uses. Range of all the waves and uses. Right? Now come to the most important chapter and best chapter, I think, right? That is optics. Limitations of Snell's law. Snell's law is not applicable for normal incidence when I equals to 0, right? Just because, as you know, sin I upon sin R is a constant, but it is not applicable when the light beams incident normally, just because there will be no deviation. The critical angle for the medium is the angle of incidence in denser medium, for which the angle of refraction will be 90 degree. And beyond the critical angle of incidence, refraction becomes reflection. That is called total internal reflection. For total internal reflection, 2 conditions: I greater than IC. 2 conditions: I, incident angle will be always greater than critical angle, and second, light always be from denser to rarer. Okay. Define power. Power is the reciprocal of focal length. Unit is diopter. How does the power of lens vary with the focal length? Power is inversely proportional to focal length. If you increase the focal length, power will get decreases. Right. Earlier we were solved these questions. You have 1.5 diopter and minus 0.5 diopter. Combined lens will produce the power of 1 diopter only. In same way, what is zero power lens? In goggle, it's zero power lens. What is zero power lens? So you have a convex, that is power is positive, and you have a convex, same power of lenses, concave and convex combining together, then you will get zero power. Okay. A blue ray light enters an optically denser medium from air. What happens to its frequency in denser medium? The frequency remains same. Frequency will no change. Frequency having no any changes in different media. Frequency will be same. In refraction, frequency will be same. Only the variation of speed. Nandita, PDF will be uploaded after the completing the session. Mention two conditions for the internal reflection as we earlier discussed. First is denser to rarer and incident angle must be greater than critical angle. Okay, mention the application of total internal reflections, optical fiber, brilliance of diamond and total reflecting prism. What are optical fibers? See, optical fibers is the thin transparent fiber of glass or plastic with coated material of lower refractive index. It works on the principle of total internal reflection. As you know, this is very common, optical fibers. I think you access internet via optical fibers nowadays. It is very easy, very common and very fast also, right? Okay. Now, mention application of optical fibers. Examine organs like stomach, intestine, etc. Field communication, transmit and receive the electrical signals. Okay. What is a thin prism? What is the deviation produced by the thin prism? Deviation is basically d equals to n minus 1 into a. N is basically refractive index. You can also written as d equals to mu minus 1 into a. Mu minus 1 into a. This is refractive index. Thin prism is one whose angle is less than 10 degree. If angle of prism is less than 10 degree, then it is called thin prism. Alright, the ray diagram formation of image is simple microscope. If you put the object between focus and optical center, then you will get the image of that object at the same side of object in large, virtual and erect. Compound microscope. In compound microscope, you have to adjust objective piece and eyepiece in such a way so that the image of objective piece lies between the focus of eyepiece and optical center of eyepiece. After finding in this region, the light waves form. Eyepiece behaves just like a simple microscope. Eyepiece behaves just like a simple microscope. That means the image of this magnified image is at virtual, magnified, right? So in compound microscope, the only working of objective is to form an image of object between focus and optical center of eyepiece. Okay, draw a ray diagram. Draw a ray diagram. See, two cases. In previous one, the final image is at LDDV, least distance of distinct division. For that, you have to put image of objective piece in between focus and optical center of eyepiece. But if you want to infinitely enlarge image, then the image of objective piece at focus of eyepiece, Obtain the relation between refractive index and critical angle, that is mu equals to 1 upon sin IC. Mu equals to 1 upon sin IC. Just because sin R, where R equals to 90, so that sin 90 will be 1. See, these are 5 markers. This is basically derive the expression for the refraction through the curved surface. You have to find this alpha, this gamma and this beta, and using the rule, see, external angle will be equal to 2 interior angles. See, just see this triangle. I am marking this triangle. In this triangle, you have to write I equals to alpha plus gamma. And if you draw another triangle. See, just focus on the green triangle. Then you will find R. How? Gamma, which is equals to R plus beta. Then R equals to gamma minus beta. And you know, alpha, beta, gamma. What is alpha? Alpha is arc upon radius. Arc that is Pn. Upon radius. PO. This PO. That is Pn upon C. In the same way, beta is what? That is arc. That is Pn upon V. And then gamma. Gamma is what? Pn upon R. Pn upon R. Okay? Okay? Just use Snell's law, mu equals to sin I upon psi. You have to find I and R and put it here. Okay, this is very simple. Now, another derivation, that is Lenz maker formula. Lenz maker formula, you have to select, that as C. This I dash is behaves just like an object for the second lens, right? So, if you are writing expression, this is considered for the first lens, right? L1. So, for L1, this is N2 upon V1 minus N1 upon U, which is equals to N2 minus N1 upon R, right? For second lens, this is N2 upon final image is V now, minus N1 upon object is V dash is equals to N2 minus N1 upon R2. Now, add up these two. While adding these two, you have two values, this and this. Sorry. This is basically N2 upon V dash. So, this term cancel out, this one add up, and the final resultant will be 1 upon F. Final resultant will be 1 upon F, which is equals to 1 upon F equals to N21 minus 1, 1 upon R1 minus 1 upon R2. This is minimum angle of deviation in prism. This is minimum angle of deviation in prism. Okay, sir. Similarly, I have lot of questions from wave optics and remaining modern physics So I will just upload. So I will just upload this PDF, right? And you can download this PDF from the description box, right? Okay, so let's close the session. And we'll meet in another session. Then after we'll discuss, right? So all the best for your examination. Thank you so much for the watching. Thank you so much.